Hello all. This video is the continuation of the data processing for additive manufacturing. In the previous video, we have seen about the different kind of file formats. One is the CAD file format, that is the step file, VRML, and IGS. Today we are going to see about the DWG. DWG is an abbreviation for drawing, which is a proprietary vector file format created by the Autodesk in the year 1982. The developers need a license to access this format in their software. So the licensing is very much important. So without licensing, we cannot use this file format. So drawing files are smaller than DXF files due to their binary makeup. Users can view and edit drawing files with other programs too, including Scan to CAD, though they are designed to use AutoCAD, used in AutoCAD. So this is a sample of the STL file format. And the STL file format, you can see standard testnet language file. You can see how the edges are represented by coordinates, XYZ coordinates, and the coordinate points also indicated. So this is how the program is developed. The coordinates are programmed in this file format. So this is how the language is fed into the machine. So according to these coordinates only, the machine starts printing the product layer by layer. So advantages and disadvantages. Main advantage is it is a simple method of representing the CAD data, and it provides small and accurate data for certain shapes that can be possible. The disadvantage is the STL file, the geometry flaws are there. Geometries may not be printed exactly, the edges may be overlapped, the clearance may not be maintained. So these kind of disadvantages are there in the STL file format. These are the common problems that arise in the STL file format. That is gaps, that is cracks, holes, punctures, that is missing in the facet. Then the second is the degenerate facet, that is all the edges are collinear. Next is the overlapping facet and non-manifold topology condition. So these are the STL file format problems. So this is a valid 3D modeling. Then it is sliced into 2D planar layers. Then it is converted into 1D scan line. You can see the step-by-step process, that is 6.7 A, B, C. And in the 6.8 you can see the image. It is the tessellated model. In the tessellated model, it is an invalid tessellated model actually. The invalid tessellated model is being sliced in the second image, and according to the slicing, you can see the third image, that is a invalid model is being scanned. So these are some of the examples of the tessellated models. So the file repair can also be done in the different data software. So you can see the different softwares. Slicer is one of the software, we can use it for slicing. So here the repair can be done by step by step. In the first image you can see the 6.12A, that is a facet is generated. Then the second facet is generated. Then the third phase is generated, and the fourth phase is generated. So the gaps are removed, and finally we can obtain the required geometry of the shape. So these are the different steps that are involved in the 3D printing technology. The steps are, the first step is the designing, then the file conversion, then slicing, then the material processing, printing, and then the post processing. So these are the different steps involved in the 3D printing technology. Thank you.